Right now, you're going to turn a tap. Water will pour out clean, cold, ready to drink, and you won't think twice about it. But for 99.9% of human history, that tap didn't exist. Getting water meant walking, sometimes for hours, every single day. For over 300,000 years, human survival depended on one simple fact. Where the water was, people were. No exceptions, no shortcuts. So how did our ancestors actually get water, keep it clean, and build entire civilizations around a resource we now take completely for granted? The answer explains cities, disease, war, and why your body still carries the instincts of a species that once lived or died by a riverbank. Let's start with the walk, because for most of human history, that walk defined a person's entire day. In many traditional societies still studied today, women and children carry the primary responsibility for fetching water. Anthropologists working with communities in sub-Saharan Africa have documented daily water collection trips averaging several kilometers, often carried out twice a day, with containers weighing close to 20 kilograms once full. That's not a chore, that's a job that could eat up 4 to 6 hours of a single day, every day, for a lifetime. Early humans didn't choose where to live at random. Archaeological sites again and again show the same pattern. Settlements cluster along rivers, lakes, and springs, not because the scenery was nice, because water is heavy, water spoils, and water cannot be carried far without cost. This is why some of the earliest cities on Earth, Uruk in Mesopotamia, sites along the Nile, early settlements along the Indus River, all grew up hugging the banks of major rivers. The river wasn't just a resource, it was the reason the city existed at all. But rivers created a problem nobody had solved yet. What happens when thousands of people share the same water source that they also use for waste? The answer, for most of history, was disease. Cholera, dysentery, typhoid. Diseases we barely think about today were once the invisible rulers of every city on Earth. In the 1850s, a London physician named John Snow began investigating a cholera outbreak in Soho that was killing people by the dozens. At the time, most doctors believed disease spread through bad air, a theory called miasma. Snow didn't believe it. Instead, he did something almost nobody had done before. He mapped every single death, house by house, and noticed something striking. The deaths clustered tightly around one specific water pump on Broad Street. Snow convinced local officials to remove the pump handle. The outbreak collapsed. It wasn't proof by modern scientific standards, but it was one of the first times in history that a disease outbreak was traced, street by street, back to contaminated water. That single removed pump handle is often described as one of the founding moments of modern epidemiology. But knowing water could carry disease and being able to stop it were two very different problems. For thousands of years before Snow, civilizations had already been experimenting with ways to move and purify water, often without fully understanding why it worked. The Romans are famous for this. Their aqueducts, some still standing today, carried water across enormous distances using nothing but gravity and extraordinarily precise engineering. At its peak, Rome's aqueduct system is estimated to have supplied the city with far more water per person than many modern cities provide today. Public fountains, private baths, elaborate plumbing, all of it depended on a network of channels that some of these ancient societies built without motors, without electricity, using only slope, stone, and patience. But even Rome's engineers were mostly solving a delivery problem, not a purity problem. Real, reliable purification came far later. In the late 1800s and early 1900s, cities began experimenting with filtering water through sand and treating it with small amounts of chlorine. The results were staggering. In cities that introduced filtration and chlorination, death rates from waterborne disease dropped sharply, often within just a few years of the change.